In this video, we are going to look at section 12.6, and this will wrap up our discussion of statistics and the data representations. Now, in the past, we've talked about stem and leaf plots and histograms and polygon shape plots, grouped frequency curves, lots of different ways to show data. And I've found that, wow, I'm pushing all kinds of buttons, I guess. I have found that when I look at data and I graph them, that one of the best ways for me is more like you see on the screen. This is an XY scatter plot, and it allows me to look at trends in the data without trying to group them together. I like to see a lot of raw data. And what we've done here is we have noted, we've called the years of education X, and we have called the score on a particular prejudice test Y. I don't know how the scores, what the scores mean. That's kind of irrelevant to our discussion. What matters is how we graph that. So the years of education on the X-axis, the score on the test on the Y-axis. So you'll go to this first point, has a 12 on the X and a 1 on the Y. You come over to 12, go up 1 and put a dot. And there we go. Here's another one that's a 13.3. So we come over to 13, go up to a score of 3 and put a dot. And that's how you create these XY scatter plots, is you plot every one of those points, comparing the X and Y. And that can be really useful because now I see where all the data are on this particular graph. I don't need to have something create a fancy line or pie chart or anything because I want to see the data themselves. However, I'm also interested in the trend of the data. Are they trending to the down? That's good English. Are they trending downward or are they trending upward? And if I were to maybe draw a line between the data, it might, if it were straight, connect something like that. Let's see if I can make a straighter line. So now I've drawn a line that goes through the data fairly well. Notice a lot of the data points are not touching the line, but they're pretty close. And so what we need to do is find out how close are the data, because if they're super close to this line, then maybe I can use that line to calculate what would happen with somebody who's not in this data set. And so we need to look at, again, how close are the data? And one of the things we will look at is a correlation coefficient. Correlation is how things go together. The coefficient describes how closely the data match the line. So here note that when the data are perfectly on the line, they all touch it, we get an R value of 1. If the data are all on the line, but it has a negative slope, the R value is -1. So all of these that trend up to the right have a positive R value, and those that trend down to the right have a negative R value. So that's really just talking about the slope of the line, and we've calculated those in this class. So we know what we're doing there. But also notice that with this second set in B, a lot of the data are not on the line. A lot of them don't even touch it. They're close, but they're not on it. And because of that, the R value has changed. It's lower than 1. And if the data get even more spread out, more points are away from the line, we get an even lower R value. Notice this is a moderate to a weak correlation. Doesn't necessarily match. And then over here, which line is it that matches the data? It's kind of hard to tell. And so we have a zero correlation. The data don't match any of those lines. So we need to understand that, and it would be even better if we could calculate it. And so I'm going to share with you the formula that we use to calculate that R value. I know it looks terrible, but also notice that we can break this down into little pieces. We know what this symbol means. That symbol means the sum of, so we're going to add a bunch of things. And it tells us here that the n value is the number of data points. So we're going to take advantage of that. Like up above here, they sampled 10 people, so there were 10 data points. N would equal 10 up here. And then notice what we're summing here is xy, which means the sum of the product of x and y. So you take the x value and multiply it by the y value. From that, we're going to subtract the sum of all the x values times the sum of all the y values. We're going to divide that by a square root. We're going to use a calculator, so no worries there. But here we're summing the x squareds. That means we're going to have to square all the x values. And here's sum of the x's again. We'll have another square root where we've got y squareds. And then the sum of the y's. So there are only a few things we really need to keep track of. We're going to need the x's and add those together. We're going to need the y's and add those together. We're going to need to take x times y and add those together. We're going to have to square the x values and add those, and square the y values and add those. And that's it. And it sounds lengthy and it sounds crazy, but I really think we can do this if we make a table. So let's go ahead and do that. Let's make a table of all of these data points. And I'm going to do it with this data set we have. And we'll see if that blue line matches the data. So we'll need all of our x values. We'll need the y values. We'll need x times y. We'll need x squared. And we'll need y squared. And then we'll need to add all those together. So the x values were 12, 5, 14, 13, 8, 10, 16, 11, 12, and 4. The corresponding y values are 1, 7, 2, 3, 5, 4, 1, 2, 3, and 10. And now I need x times y. So 12 times 1 is 12. 5 times 7 is 35. 14 times 2 is 28. 13 times 3 is 39. 8 times 5 is 40. 10 times 4 is also 40. 16 times 1 is 16. 11 times 2 is 22. 12 times 3 is 36. And 4 times 10 is 40. Now in the next column, I need to square the x values. So I've got 12 squared, which is 144. And then 5 squared, which is 25. And then 14 squared, which is 196. 13 squared is 169. 8 squared is 64. 10 squared is 100. 16 squared is 256. 11 squared is 121. 12 squared is 144. And 4 squared is 16. Now I need to square the y values. So looking at the column of y values, I'm going to square each one individually. 1 squared is 1. 7 squared is 49. 2 squared is 4. 3 squared is 9. 5 squared is 25. 4 squared is 16. 1 squared is 1. 2 squared is 4. 3 squared is 9. And 10 squared is 100. Now notice in my formula, which I have written over here on the left-hand side, we can see what we need. We needed n, the number of data points. We've got 10. We need the sums of all of these columns. So I need to add all those together. So I'm going to grab my calculator since that'll be perhaps faster. 12 plus 5 plus 14 plus 13 plus 8 plus 10 plus 16 plus 11 plus 12 plus 4 is 105. Adding the next column, 1 plus 7 plus 2 plus 3 plus 5 plus 4 plus 1 plus 2 plus 3 plus 10 is 38. Probably could have done that in my head about as fast. Maybe even faster. The next column, 12 plus 35 plus 28 plus 39 plus 40 plus 40 plus 16 plus 22 plus 36 plus 40 is 308. Summing the next column, 144 plus 25 plus 196 plus 169 plus 64 plus 100 plus 256 plus 121 plus 144 plus 16 gives me 1235. And then summing the last column, 1 plus 49 plus 4 plus 9 plus 25 plus 16 plus 1 plus 4 plus 9 plus 100 is 218. Now I have all of those sums, so I can plug those into the formula. R equals n, which is 10, times the sum of the xy's. That's down here, 308. And you see that we took that time to create the table, but now filling in this formula is going to be quick. We know the sum of the x's, that was 105, times the sum of the y's, which was 38. And we're going to divide that. And this is where it might get a little tricky in our calculators. We're going to have the square root of n again, which is 10, times the sum of the x squareds, which was 1235, minus the sum of the x's, which is 105, and it says we need to square that. I'm going to come over and end that square root and start another one. In my calculator, I may have to hit times between those two. So now I've got 10, which is the n value, times the sum of the y squareds, which was 218. And from that, I'm going to subtract the sum of the y's, which was 38. And then I need to square that. And that's where that will end. Now I just plug that into my calculator. Once again, I'm going to take advantage of that fraction button to help make sure that things happen the way I want. So 10 times 308, and from that I'm going to subtract 105 times 38. Then I'm going to hit the down arrow to get into the denominator, and I'm going to start the square root. So I'll have 10 times 1235 under that square root, minus 105 squared. I'm going to hit the right up button to get out of that square root. And then I'm going to open another square root, where I will have 10 times 218. And from that, I am going to subtract 38 squared. I'll hit enter, and I get negative 0.92. I was helping a couple of students and found that they were hitting the right button to get out of the exponent, but they were still under the square root when they started the second one. And so that gave them an error. Make sure you're outside of that bottom square root before you start the next one. But you should get a negative 0.92. Now 0.9 is really close to 1, which means we have a pretty strong correlation. The data, but dots, are pretty close to that trend line that we drew. And that's going to be really useful for us. We will be able to, from that, interpolate a little bit. Now that we know that our trend line matches pretty closely, we could potentially get the formula for that trend line. And if we had that, then we could say, well, then what would happen if somebody had, say, 7 years of education, which doesn't appear on the table. But now we could plug that 7 in for X and see what the Y would be. But let's see, we've got here the calculation for our formula, and you recognize that Y equals mx plus b. We used that quite a bit for a while there. Now they tell us that m follows another formula just like we saw. I'm going to write this one in a slightly different color. Maybe it will stand out a little better. The m value is, remember, m represents the slope. So the slope of that trend line would be the n value, which is 10, times the sum of the xy's, which is 308. From that, we're going to subtract the product of the sum of the x's and the sum of the y's. So that looks just like the numerator of our r calculation. In the denominator, though, it's slightly different. We don't have any square roots. We still have n times the sum of the x squareds of 35 minus the sum of the x's, which was 105 squared. So it's kind of like the left-hand side of the denominator there without the square root. And that's fine. Remember, slope is rise over run, so it kind of makes sense we would use those x values there. So in my numerator, I'm going to have 10 times 308. From that, I'm going to subtract the product of 105 and 38. Then I'm going to divide that by 10 times the product of 1235. Now, I did use my fraction button. If I didn't, I would want to put maybe an extra set of parentheses around this whole denominator, just to make sure my calculator put that whole thing down there. Since I have the fraction button, I didn't worry about that. But that gave me a slope of negative 0.69. And we expected a negative slope because it drops to the right instead of rising to the right. Now that I have that, I can find the b value, which is the sum of the y's, 38, minus m, which we just calculated, negative 0.69, times the sum of the x's, 105, all over n, which in our case is 10. So now I'll plug that into my calculator. 38 minus the product of negative 0.69 times 105. And I'm going to divide that by 10. And I get 11.04. So we could just call that 11. I think that would be all right. So where it crosses the y-axis is up here at 11. It's, I think mine is trending a little bit higher than that, but it just means I didn't draw my blue line exactly in the best spot, but it's pretty close. So the formula for the blue line is y equals m, and we calculated m as negative 0.69. Keep the x. Remember, y equals mx plus b, which we calculated as 11. So that is the formula for the blue trend line that goes through our data points. Now I asked you, what would the score be for somebody with 7 years of education? Looking at the data points, we don't have a 7 there anywhere. But we have the equation of a line. So what we want to do is say, well, then years of education, which is the x value, would equal 7. So what would this equation be if x was 7? Well, y equals negative 0.69 times 7 plus 11. And when I plug that into my calculator, I get 6.17. So I'm going to call that 6.2. So here at 7, if we go up to 6.2, we would be on the line, just like we expected. And that's how we would make that sort of solution and evaluation. So we go ahead and put together our table. We plot it using data points, and we create a trend line. And then we check the R value to see if that trend line matches the data well enough. And a 0.9 is a really strong correlation. And so I'm feeling good about that. Now I want the equation of that trend line. So I solve for M and B using the formula I was given there. And then I plug those into the y equals mx plus b. And now given any x value, so any number of years of education, I can plug those into the formula and see what the corresponding score probably would be on that given test. And that's how we'll use that bit of information. So now let's look at the answer to the question, what do I do if I'm extrapolating to an entire population? And what I need to do is compare the R value I got to these alpha values. And it'll be based on the N value, the number of data points. Now we had 10 data points. And so this is where we sit on this particular table. Remember our R value. And I'm going to take the absolute value of that R value, which gives me a positive. So the R value was negative 0.92. The absolute value would be a positive. Now the question is our R value larger than the alpha values in this particular row? If it's larger than this first one, then that means there's a 5% chance we're wrong if we say that our data match the rest of the population. If our R value is larger than this one on the right, that means there's a 1% chance that when we say our data match the population, that we're wrong, which means there's a 99% chance we're right. So we will compare our R value to this table to see whether or not we really could extrapolate our trend line to a larger population. Now remember, correlation does not mean causation, and that's a favorite phrase for a number of people out there. And what that means is just because the trend line goes this way doesn't mean that it's always true. For example, we might compare, say, grades in class, and they might be a curve like this. Well, let's say that also matches a pile of dirt outside. Does that mean if I cut some of the dirt off, that your grades will follow that? No, one doesn't cause the other. However, they're strongly correlated. They're well aligned. There's no doubt that those things match. But one thing doesn't necessarily cause the other. Just because one thing is going up and another is going up at a similar rate doesn't mean that one thing caused the other. It just means they're moving at the same rate. And that happens all the time in this world. So you need to watch out for that. If somebody shows you a graph and says, look, these things align, of course one thing caused the other. Maybe it did. But maybe it didn't. Just because there's a strong correlation does not necessarily mean that one thing caused the other. And so you'll have to do more research. There's a chance that there's some causation there, but it's worth taking the time to look at the data, do a little research before you just accept the fact that one thing truly did cause the other. Well, that's the end of 12.6, our last lecture for the semester. I hope this has helped. And as always, if you have questions, let me know.